Hello everyone, my name is Malvika Lewis. In this screencast, we will take a look at a complex aggregate query in MongoDB Compass. MongoDB Compass is a graphical user interface tool for MongoDB that allows you to visualize and explore your data with ease. It provides a graphical interface for performing various operations on MongoDB databases, such as creating and managing collections, creating and executing queries, and analyzing the performance of your queries. For this example, we'll use data related to events and functions. The data consists of 1000 documents where each document represents information about a particular event or function. Let's take a closer look at the data. Each dictionary contains the following fields: ID, a unique identifier for each event; year held, the year in which the event was held; function type, the type of function or event such as wedding, corporate event, retirement, or birthday; food choice, a list of food choices available at the event such as beef, chicken, lamb, or fish; number of guests, the number of guests who attended the event; alcohol, a list of alcoholic beverages available at the event such as Guinness, Heineken, whiskey, or wine; soft drinks, a list of non-alcoholic beverages available at the event; duration, the duration of the event in hours; disc jockey, information about the disc jockey or DJ at the event, including their name, fee, availability; and last is the venue, which is the information about the venue where the event was held, such as name, city, type, capacity, and acoustics. Now, let's have a look at the complex aggregate query. The query is already written for you. So, what are the venues with good acoustics that have hosted at least 50 events, and what are the average number of guests and acoustic ratings for each city in which they are located? Also, how much alcohol and soft drinks have been served at these events in each city? So, this is a query written. Now, let's copy the query which is enclosed within the aggregate function. So there are two main ways to run an aggregate query in Compass. You can either use the text editor or stages option. So let's see that. Here you can see the text editor option and the stages here. Firstly, let's explore the text editor here. Now we need to copy and we need to paste the query enclosed within the square brackets. And this is the output of the query. First, let's explore the query here. So here's a breakdown of the query. This match function, this stage filters the documents in the pipeline to only those that have a non-null venue name. This stage groups the documents by venue name and counts the number of documents in the group by using the $sum operator here. The next is the match stage, which filters the groups to only those that have 50 or more documents, which means there were at least 50 events at that venue. The next stage is the lookup stage. This stage performs a lookup on the same collection to get additional information about each venue. The lookup stage joins the function collection with itself on the venue name field. In the given query, let is used to define a variable named venue name and assign it to the value of the ID field. This variable can then be used in the subsequent stages of the pipeline. The purpose of creating this variable is to allow us to use the ID field in the subsequent $match stage. Since the ID field is not accessible in the match stage, when used with the expression operator, we create a variable in the lookup stage and reference it in the match stage. For example, in the subsequent match stage, we can use the $venue name variable to match the documents where the venue name field is equal to the ID field. Here, $venue name is used for reference to reference the venue name variable that was created in the lookup stage. It uses the expression operator to compare the venue name in the joined collection to the ID field from the previous stage. It then groups the joined collection by venue.city. Acoustics. This part of the aggregation pipeline is calculating the average acoustics rating for each city where events have been held at a particular venue. The acoustic rating is based on the values of the venue.acoustic field, which can be one of the three values: poor, fair, or good. The calculation uses the switch operator, which evaluates a series of conditions and returns a result based on the first condition that evaluates to true. Here, the switch operator has three branches, each of which corresponds to one of the possible values of the venue.acoustics field. For each branch, the equal operator is used to compare the value of the venue.acoustics to the corresponding value poor, fair, or good. If the value match, the then expression is evaluated and returned as the result of the switch operator. In this case, the then expression is a numerical value, 1 for poor, 2 for fair, and 3 for good. If none of the condition in the switch operator evaluates to true, the default expression is returned instead. In this case, the default expression is 0. Finally, the average operator is used to calculate the average of the values returned by the switch operator for all the events in the given city. This gives us the average acoustics rating for events held at venues in that city. Here, it calculates the average number of guests, total alcohol served, and total soft drinks served for each city. The next stage is a group stage. This stage is a pipeline stage using the group operator to group the documents that match the previous pipeline stages. The ID value is set to null so that all matching documents will be grouped together as a single group. The cities field is created using the $push operator to add an object with three fields: city, acoustics, average guess. The value of these fields come from the fields in the matching documents ID, acoustics, and average guess. It calculates the overall average acoustic, average number of guests, total alcohol served, and total soft drinks served across all the cities. The next operator is the unwind operator. In this stage, the unwind operator is used to break down the cities array field into individual documents so that it can be processed further in the subsequent stages of the pipeline. Each output document will contain the same values for all the fields except the cities field, which will contain only one of the array element from the original document. The output documents will be duplicates of the original document with different values in the cities field. The first projection is used to transform the fields of the cities array produced by the previous pipeline stages into top-level fields of the resulting documents. This is done to make it easier to analyze the data in a tabular format. The second projection is used to rename and select the fields that will be included in the final output document. In this case, it selects the original ID, the number of events field, and the city stats array that was generated by the previous pipeline stage. Lastly, we'll sort the result in the descending order by citystats.acoustics and citystats.averageGuests. Now let's see how to run an aggregate query in Compass. You can either copy and paste the query within the text editor, so you can see that the output is generated here, and also the various stages are assigned in the pipeline as shown here. It automatically assigns the stages in the pipeline. The other way of doing is by going to the aggregate section and manually adding stages. So if we go to the query here, the first stage is a match stage. So we need to select the query within the match stage. Select match from the drop down and paste the query here. So it filters a record based on the condition which is set within the match field. This is another way of assigning stages to the aggregate functions. For this demo, we will be using the text editor. Now, by clicking the stages here, we can see that various stages are automatically assigned to the query here. So there are 6 stages here. The first one is match, second is group, third is another match, fourth is a lookup stage, fifth is a project stage, and the last is the sort stage. Now let's explore each stage individually. The first stage is a match stage. Let's expand the stage. So here the stage input, it filters the documents in the input collection by matching only the documents where the venue name exists. The venue name exists. This means that only the documents that have a non-null venue name field will pass through the stage to the next stage of the pipeline. Let's expand all the fields. Here, the stage output. The output retains the same document structure as the input, with the documents that did not match the filter condition being excluded. So all the documents where the venue name doesn't exist will be excluded from the stage output of the first stage. Let's close this window and moving on to the next stage. The next stage is a group stage. The input to the group stage is the output from the previous match stage, which is a set of documents that contain the venue name field. The stage output, let's expand again. The output of the group stage is a set of documents that contain 2 fields, ID and number of events. The ID field contains the name of the venue, while the number of events field contains the number of events that occurred at that venue. So next, let's close this. The next stage is a match stage. So here, the input to the third stage is the output from the second stage, which is a group stage. The second stage group returns documents that contain ID field with a unique venue name and the number events field with the total number of events held at that venue. The third stage match, which it filters this output and retains only the documents where the number of event field is greater than or equal to 50. So here you can see the output generates only 2 records or 2 documents where the number of events is greater than 50. One is 53 and the other one is 51. Now moving on to the next stage is the lookup stage here. So the stage input. The output of the previous pipeline stage is used as input for the lookup stage here. It consists of documents that have been grouped by venue name and filtered to include only those documents that have a number of events which is greater than 50. Now for the output of the lookup stage, we have a new document that contains or combines information from the original document with information from the function collection using the venue name field. Each document in the output contains an array called citystats. It contains an array called citystats, which includes information about the average acoustics, average guests, average and the total alcohol, total soft drinks across all the cities. So next, close this and moving on to the next stage, which is the project stage. Here, let's expand this. The stage input to this is the output from the previous stage, which includes the following fields such as ID, number of events, and the city stats, which includes all the statistics of the number of guests, the acoustic rating across all the cities. And the output of this stage is a modified document with the following fields, which is number of events, the ID, and the city stats. The last stage is a sort stage, which sorts the cities with the best acoustics and the highest average number of guests. This is the final output of the query. I hope you understood it well. Thank you.